lecture, we will conclude the again a connection of QGIS with other external in the services that you see before for data, but we can also enrich our software with some additional also functionalities, not only data. What it means? It means that QGIS offers some capabilities to user to develop their own, they call it plugins, for example, or algorithms that can be then shared among the community and can be reused by anyone because they kept the license, the open license of QGIS. And you will use some of these tools in the next modules where you have the data processing, and so you will learn better how to use single functionalities. What we see now is just how we can access to them or put them in our software. On the webbook, the chapter of reference for this lecture is the 2.3, so extending QGIS functionalities. The first things we just saw briefly, and then you will use it in the next lecture. It's about the processing toolbox. If you go on your QGIS, you already use some of these. You see some of these. Can you see my screen just for confirmation?
Yes, we can.
Okay. So you already use some of these commands that are here in this bar, for example, and those are the famous, you don't know if you record, core functionalities. So those are features of QGIS that are already there when you install your software, and that are presented or put in evidence on the interface because usually are the most used commands, no, of QGIS, or more traditional one. But I told you that QGIS offer the possibility to customize a bit your even the interface to use or put some buttons of the functionality that you use more for your particular work, for example. The first place where we can find additional functionalities to the one we see here in these little windows is the processing toolbox. And this processing toolbox, if you open here, following the instruction that are here, you should have it already in your QGIS. It's nothing more than a list or a catalog of all the QGIS algorithms that can be used for data processing. And we can also have some, you see here, some additional algorithms that comes from other software. So this is the famous integration that QGIS has with other free and open source software like GRASS and SagaGIS. Some of the functionalities, of course, are doubled because we have the same, maybe the same processing algorithm both in GRASS.js, and then there is a version for QGIS, but everything is inside this place. So to look for functionalities, you can simply, what you need to know is just like the name or the alias of the operation you would like to do. And I don't know, buffer, for example, you will know, you see, you can search directly here which algorithms are available for doing this buffer, which is an operation on vector data. And you can select one of the functionality that are here, like this, by clicking, and the algorithms are available for being used through a graphical user interface.
Excuse me, Daniela, wouldn't it be possible for you to switch with the English version of the QGIS?
Oh,
because
yes.
Okay.
Sorry.
Thank you.
Yes, I need to restart it. I added on the 3.5 version, 3.10 version. QGIS. Here we are. By the way, so we saw that there is nothing more to do on that. We saw how to access this library of functionalities from QGIS. Then there are additional things you can do through the processing toolbox, beside the use of the functionalities that are there provided. One is the scripting. So it means for advanced user can command QGIS through programming. So through Python programming. This is a programming language that enables the interaction with the software. And also you can create what is called the graphical models, which are nothing more than a chain of operation that you can pick from the processing toolbox to create really complex workflow for data processing. You will see also in the next, in the final lecture of QGIS and analysis tools, the use of this graphical model. And it's really powerful because without the programming knowledge, you can create or automatize really the processing or really complex processing of the data. Here we have our project. Let me just put again back all the file, just to have a reference. And here we are. Second things, and here we require you to do some work, so please keep your QGIS open, are plugins. QGIS plugins are modules or specific little software that can be used inside QGIS. And those plugins are usually created by, let's say, by external user or third-party user. And then, if approved by the core developer of QGIS, they can be shared directly from a unified repository where all those plugins stays. Plugins are really a lot. So if you open this QGIS plugin repository link you find in the webbook, you can access this repository where there are plenty of different plugins, and you can, of course, try to understand if there is a plugin that is useful for your purposes, and understand who developed it, what the plugin does, how to install it if there are some specific requirement before the installation, which are the history of this plugin, so you can see all the versions of the plugin and so on. There are really a lot. There are some that are with the time they became what we call core plugin. So it means that someone developed those plugins, then the user start to use the plugin was so stable that those plugins are already included in your QGIS when you install it. So they became part of the core software. Other are just plugins that are still there, not provided by default with the installation of QGIS, and other more are experimental. That it means they are still in development, or they are used from a really small community of users, so they are not included in your default installation. Which plugin we will look together? Basically two. We are going to see what is Quick Map Service plugin. That is a plugin used for adding base map to your projects. And a second map, which is the Quick OSM map, that is used to download OpenStreetMap data, and we will see what they are and how to use it. So let's do it together. If I want to install a plugin, what I have to do? well, I need an internet connection first because I need to download some packages. I can do that through the interface of QGIS, especially here. You have a plugin section, and go on manage and install plugins here. If I click on it, you see that I have this list that is exactly the list we saw before on the website. So you can query or explore all the plugins that are there and look at the information that the developer provide and browse or even search here some plugin. And so let's do it. Let's search this quick map service. Could you find it? Okay, so here you can read what is necessary to know, and you can install it by simply click here on the bottom right part of the screen, install plugin. So let's install this plugin. You see it will be something really fast for most of the plugins because they're really small pieces of software.
Sorry, I'm lost. Can
Yes.
you repeat which file or what file is what we have to select, please?
Okay, so once you are in the main interface of QGIS, you go on plugins, manage and install plugins.
Yes, I'm in it.
Okay, here you have to look for quick map services. You can use this search bar and look for this.
Quick maps. Okay, perfect.
Okay.
Thank
Once you find it, you just select here and click. You should have, if you didn't do it before, install plugin.
you. Okay, perfect.
Okay.
Great. Thank you.
Perfect. So now we have these new functionalities that we added to our QGIS. Let's see what this quick map service does. I can close the plugin tab here. I don't need it anymore. This plugin is once you install a plugin, it finishes somewhere here. So there are some general plugins that stay here in the plugin window. There are some plugins that finish in the vector menu. There are some plugins that finish in the raster, the database, and in our case, our plugin is a web. It is connected to web maps, and so it's under web. Could you find it here? Okay, I imagine yes. So let's, for example, you might have not this full list. I see there is a, okay. You might have not this full list of maps, correct? Because this plugin allows for a small trick to add many base maps to your projects. So what you should do before using the plugin, and you should do just once, then all the base map will be available. You can go, just follow me. You can go down here in settings. If you click settings, a little panel will appear with some settings option, of course. The last panel is called more services. If you go on more services after settings, under settings, and you click on get contributed pack, you are actually connecting a bunch of new base map with respect to the default one you have at the first opening of the plugin. Why? This is the good part, the nice part of QGIS. What's happened here? it happened that some of the maps, that some base maps, so the map you put usually at the base of your mapping project, are open, and there is no need for, I don't know, an account or to pay or to have some password, let's say, to use them. The developer of this app, by the way, found a way to provide you some additional maps that are in generally close, or they require at least you to have an account on the system that provide those maps. I don't know why. I don't know how they do actually, but they tell you that if you accept this, if you want these more maps, use it at your own risk, because they don't guarantee all the maps works properly and so on, because it's a borderline operation what they are doing. But okay, this is something that we can use, and nobody will. So we are let's say in charge of doing that. So once you get this contributed pack, you can close it or save and go back to the plugin. So web, quick map service, and now you should have a really big list of base map. So let's see what base map is. For example, go on I don't know, Bing. You know Bing Maps, and let's select Bing satellite, for example. You see, now you've added to your project, to your mapping project, a base map, which is a satellite imagery or satellite base map provided by the Bing. And these are really high resolution maps, so you can zoom in and see even cars or even people that are walking. Could you add your first base map to QGIS?
Yes, I can see it, but I can see that the position of the map is not correct in this case. The area that we are studying is in the middle of the Mediterranean Sea.
Did you use the Bing map?
Yes.
But which is the reference system you set up here? Is the same of mine? It shouldn't be a problem, because actually the reference system should be managed. That's quite strange. Try to zoom in or to change base map. So as some of this connection to those base map is a bit experimental, they may show some different behavior depending on the country or all the operative system you are using. Sometimes happen. That's why the developers say use it at your own risk. So if you want to try, you can maybe change the map and going on a Google map. So Google satellite, that should be almost the same of Bing actually. My maps are correctly there without setting any parameter. So maybe it's a temporary malfunctioning or. By the way, this is how we add maps. We can also add other types of maps, and in particular, we will add this base map. If you go on Quick Map Service and you go down, the last one is the OSM. That stands for OpenStreetMap. And we can add, for example, OSM standard. Why we are doing that? Because we will use this for the next step. So this OpenStreetMap, someone of you already listened about OpenStreetMap or is familiar with this background map that I added now? No? Yes? Okay. OpenStreetMap actually is farther more than a base map. So it's not just a picture that we put down there under our vector data to make your maps nicer. But today, OpenStreetMap is the it's the database of geographic information is the biggest in the world. And the best part is that it's open and is created by user. So I want to just introduce you OpenStreetMap through a really short video that, of course, is a bit limited, but it might help you in understanding what is behind the map you have now added to your project. Because then we will try to download some of the data you see there. So can you see the screen with? Oops. Can you see the screen with the video?
Yes.
Yeah. Okay. I can even share the link, so maybe you can use it or reuse it with your students. And it's plenty of nice video on OpenStreetMap, but this one was the shorter one. And so what is OpenStreetMap? Let's just keep attention for a couple of minutes to try to understand better.
I don't know if we're supposed to have the sound because you don't have it.
You don't have the sound?
No.
Whoa. Okay, so that's why we're not sure about video. Can you we can stop 2 minutes and you can see the video by your own through using the link I send you. Yeah.
Super.
This is nothing more than a curiosity, actually, but I would like you to know that. Second link I share with you, there is the time lapse of the creation of this open screen. And this is really impressive that we usually show to our students because it really makes you understand how, which is the effort for mapping. Okay. But those were just curiosity that are not really close functional to our work. But so everyone saw the video, yeah, okay, I believe. So OpenStreetMap, as I told you, it's one of the most important projects for mapping that it was developed in the last almost 20 years. And what you saw here as the base map is no more than a rendering of a vector database. You see, if I zoom in, I get more and more details. So this is kind of vector database of geographic information that is contributed by the user. So everyone has some tools. So it's an ecosystem. OpenStreetMap is an ecosystem of tools that allows user to add and contribute to the map, like going on the field with a GPS device, or stay home using satellite imagery to draw the boundary of their home or the football pitch that is near the house, adding attributes as all the vector data format. And then everything is kept, also the history of each object is available in the database. And the data that can be used for simple purpose, like using them as a base map, as we did here. But we can also extract selectively some of those data. So just to let you understand better how everything works in QGIS, in OpenStreetMap, and how we can ask data from OpenStreetMap, let's see, for example, how we can map something in OpenStreetMap. This is, we call it a sandbox. I send you the link. So it's an application that allows you to play with OpenStreetMap by adding data without actually writing those data in the real database. Okay. And you need to log in, of course, but it's exactly a copy of one of the editor of OpenStreetMap that allows you to understand how we can add something to the map. So I'm here, I want to edit my map. We won't go for deeper detail here. You can discuss later or another occasion. Let's start my change. So using, for example, this is a way of contributing to OpenStreetMap, using, for example, my computer and a satellite imagery, I can map a house. Again, this is a vector data model, so I can map the house using a point or using an area. In this case, I want to use an area. And user, what they do, they just draw the footprint of the building or all the other things. Then, as any vector data model, we have to add some attributes, and OpenStreetMap asks for attributes, and those attributes are saved in the OpenStreetMap object as we call it KM value feature. So it means that I can add a lot of attributes saying this is a building. Oops, sorry. This is a building. And then I can state that is a building, yes, which is of course, if I don't know anything about this building, I use this couple of key and value objects, so building, yes. Or I can say this is a building residential, this is a building house, but as I don't know anything about this building, I just map it, I leave it like this. So this is the minimum information that I send to OpenStreetMap. Then this information, this data can be saved, and it will become part of the OpenStreetMap database. So this is how we map things in OpenStreetMap. Well, at least this is our way to map things in OpenStreetMap. So let's come back to our plugin. There is a plugin. There are many ways to edit these OpenStreetMap data, but there are also many ways to retrieve them. So we can use, what we can ask, for example, to the OpenStreetMap database, all the buildings that are in a certain area. How we do that? Let's go on QGIS, and again in plugin. So please, now it's moment to play. So follow my screen, or try to follow the instruction of the webbook. If we go on the plugin, we go manage and install plugin. And in this case, we need to look for quick OSM. This one. Every one of you could find it. This one. Once you have found it, you can install it. Simply click install. So the first, let's do a little exercise to understand how this map is used. We can zoom on some of our data or some of our area. This is one of the lakes we have in our database. Let's do it on let's zoom on a small area. Why? Because now we are trying to request from the web some data from the OpenStreetMap server in a specific area. And if we ask for a big area, this will take more time, simply, but of course it will be possible. If we go now on vector, because this plugin, it works with vector because it works with OSM. If we go on vector, there is the quick OSM plugin. And let's select quick OSM, quick OSM. The interface of the quick OSM plugin is no more than a kind of compiler that allows us to put some information about that help the system to ask a specific object. You remember that I told you that all objects in OpenStreetMap have some attributes as key and value in a key value format. So it means if I want a school, probably I need to request for key school, building equals schools, or there are other tags. Tags of this key value couple is called tags in OpenStreetMap. If you go on the webbook, there is this link to the tags of OpenStreetMap, and these explain you how this data model is called for attributes is created or is implemented. If you want some additional information on how things are mapped in OpenStreetMap, I'm sending you now a link. And these links, you see, you can search for objects of your interest and identify them through a key value couple. So, for example, if you go down here is for skiing. So there are a lot of key and value. So you must look and search for the best one or the most used one. For example, if you want the gondola, ski gondola that are in your area, you just need to use key aerial way gondola. This is a really strange case, but there are more common cases. And here there is the list of the tags if you are interested in. In our case, we will do something really simple. We want to extract the building that are schools, or better, let's do it for general. Let's do on only building, so we will get all the building, because here you see there are some possibility, there are some ambiguities in this key and value as the project is created by the community. If you ask only for building school, you might lose some of the schools because they have another tag. Okay, what is the most common tag, especially for building, of course, is building yes, because everyone at least state that the building is a building. Okay, and let's do that. How we can do that? Let's go on the quick OSM query. We can use the canvas extend as area. So it means that we are asking buildings that are inside our screen or we can use the extension of a layer, or we can even search for a city, I don't know, Milano or your city, and OSM will try to understand the extension of the city using some internal services that he has and ask data for this specific city, for this specific region. In our case, let's use this canvas extend. For keys, we will use building, and for value, we will use yes. So you see, it's the creation of this query is guided somehow. Then there are some advanced parameters that you can set. As I told you, the building can be mapped, for example, as point, as polygons. There are these are the real name of the object in the data model of OSM. We won't waste time on that, but we will simply, you know that everything is explained in the links you find on the webbook if you want to get deeper in OpenStreetMap. In our case, we want just to run this query, so this query to the OpenStreetMap server to get the building in our map area. So if we run the query, we need to wait for sure. Bigger is the area, higher is the time we have to wait.
Sorry, I obtained an error when I run query.
Me too.
Which kind of error?
Well, it tells error in the logs in the quick OSM panel, and I repeat because it, and please report it to GitHub. It's a red.
You are using which version of QGIS?
3.16 on Mac.
Okay, I didn't test that on the Mac actually. I don't know if might be some, the Windows user could download that.
Yes.
So it probably a problem of the version of the plugin on 3.16 for Mac OS at this point. Something I'm also a Mac user somehow, and sometimes you have this issue. If you need a special this plugin, you can, I don't know, downgrade. It's not the case because for this course you will use, but there are differences, or there are errors that appear on the same version of QGIS for Windows, Mac, and Linux because they are parallel distribution. No, so sorry for that, but it might be just a problem of the Mac on that. So this is, by the way, is not such important. This is the procedure. Important you understand what this quick OSM does. So the query was run, and if I come back to my map, you see I have three different. I have now three different layer that came from my query. Let's even close lines and or even remove line and points, which are the minority of the building tag like this. And you see here, I got the building that are mapped, not all, because we ask only for the building, yes, probably if then we ask for churches and we ask for other things, we get all the other. But you see, these exactly are the building, yes, which are in the OpenStreetMap database in this moment over this area. So this is a way of enriching your data or retrieving some data of interest using external services, and in particular using OpenStreetMap, which is this wonderful system that is open and everyone can use. You can use for your classes. You can use for any purpose. Okay. Last things we will do is to install another plugin. We won't see anything about it, but this will be useful for the remote sensing part. So please, just last effort with me. Go again on the plugin and install the plugin that is called SCP, Semi-Automatic Classification Plugin. This is a made in Italy plugin. It's really famous because it's really complex, actually, because it allows processing really complex data. It has a lot of panels. It has some logic, but it was one of the premier plugin. As you see here, more than around 100,000 downloads. So it's really, really used. And it's used exactly for manipulating remote sensing images and so on. So you try to install it. This will take a bit longer than the other plugin, probably because, no, it was quite fast. Once you install this plugin, many panels appears around. So you are free of leaving them there. So now when you install, you can close the plugin manager. You are free to leave them there, or you can go here where there is just gray area with no buttons, and do right click and remove some of these SCP stuff. Click on SCP, then probably you need to activate it again. But when you see this SCP something, you can remove them for the moment, just to not affect the visualization of your QGIS interface. Of course, if I enable them, I will see them back. In this case, this plugin went under a specific, you see, place up here. So it didn't finish under vector, raster, database, web, but as is a really complex plugin that implies vector, raster, database, web processing, and so on, he has his own space in the menu here. So you should have, and in any case, the access to all the functionalities from up here. Okay, so that's all. We learn how to install the plugin, and we learn how to find processing algorithm in QGIS. We knew also something about OpenStreetMap that is even for didactic purpose, in my experience, is really nice to show, because it makes students understanding what are spatial data and how to map, and it's really a nice experiment. We also do mapping, for example, with children from 8 years old or even younger, and we could have some nice experience with mapping in OpenStreetMap as a first step into GIS and so on. So this is just my suggestion, but you have some clue about that. There are questions? No questions? Someone said, Daniel, it seems that the key and value becomes from dictionary of Python. Yes, let's say key and value format is in Python is called a dictionary. The query is run in a in a specific syntax of the API of OSM. And also, I don't know, in JavaScript there are, or in Java or in other programming languages, there is this format of storing attributes. So actually all the not relational database, they are called like this, works with this key and value format. So it's not strict connected to Python, but of course, yes, it has this, also the Python version of it. But with this call, is not directly connected with Python in this specific case. Other questions?